Hello friends, my name is Abhishek Srivastava. Today we are going to do the topic height and distance of subject maths of class 10. So we are proceeding with the questions. So the first question is, there is a cliff. You can see on the board there is a cliff. A cliff is a vertical, some kind of a vertical mountain, you can say a vertical hill. We have to find, this is having a height of h from the ground, and here there is a ship which is coming to this cliff, and at this point, suppose this point is A. Here it is making an angle of 30 degree. The ship is making an angle of 30 degree with the top of the cliff. It is moving towards the cliff, and at point B, closer to the cliff, it is making an angle of 60 degree. Suppose this point is B. So here we have to find the time it takes to move from point A to the foot of the cliff. Suppose the foot of the cliff is point O. So we have to find the time the ship takes to reach from A to O, and here the time it takes from reaching from B to O is 3 seconds.
30, 40, 50.
So this is our question. So we have to calculate the time it takes to move from point A to O. So so
I love you.
man. So so now I think you all might have understood this question. So we are going to understand this question once more. This is a very, very important question. This comes in exam. So here it's difficult because we have to find the time, and if we consider the height and distance, then we are dealing with only height and distance. So here the height of the cliff is h. So we are going to understand this question once more. Here there is a right angled triangle. It is making an angle of 30 degree with the top of the cliff, and here this point is A, and here it moves closer to the cliff, and it makes an angle of 60 degree from the point B. So here you can see, here the angle is 60 degree and this height is h. So this distance we can write it, its velocity is v, and the time taken is t. So in terms of distance we can write vt. So the length of AB is vt, and here BO length will be, it takes 3 seconds, so it will be 3 into V is the velocity, so it will be 3V. So now we can write tan 30 degree. Tan 30 degree is opposite side, that is height, upon AO. So it will be height upon AO. We can write AB plus BO. So AB, it will be VT and BO is 3V. So we can write value of tan 30 degrees 1 upon root 3 is equal to H upon taking common V. So it becomes V into bracket. It will be 3 plus T. So this is our first equation. So I think you have understood this question, this equation. Now we are going to make the second equation from this smaller right angle triangle which is having an angle of 60 degree. So we can write tan 60 degree is equal to opposite side upon base. So we can write H upon BO. Value of BO is 3V because it takes 3 seconds to reach here at point O. So value of tan 60 degree is root 3. So it is root 3 is equal to H upon 3V. This is our second equation. So dividing the first equation, you can see the first equation by second equation. So we can write here 1 upon root 3 upon 1 is equal to H upon V bracket of 3 plus T upon H upon 3V. So here H gets cancelled and VV gets cancelled. Here we are simplifying this, so it will be reciprocal of this. So it will be 1 upon root 3 into 1 upon root 3. That will be the square of root 3, that is 3. So 1 upon 3 is equal to 3 upon 3 plus T. So I think this much you all have understood. So now we are cross multiplying it. So it becomes 3 plus T into 1. So it becomes 3 plus T is equal to 3 into 3, that is 9. So now we can write T is equal to, this 3 goes to the other side. So it becomes 9 minus 3. So here the time becomes T is equal to 6 seconds. So I think you all might have understood this question. This question is very important because it can come in your exam, because here we have to find its time, and in height and distance we deal with distances. So you have to first find the time in terms of distance, then you can proceed with the question. This is the important thing to be understood here. So I think you all might have understood this question. So now we are proceeding to the next question. So I am rubbing the board. So the next question is, so the next question, there is a tower and there is a building which is having an height of h, and it sustains an angle of alpha from a point A on the road, which is at a distance of A from the foot of the building, and the one end of the road. The other end of the road sustain is at point B, and its distance from the foot of the building is B. You can see it in the diagram, and it is making an angle of alpha from the top of the sustaining an angle of elevation from the top of the building. So here we have to find the distance AB, the width of the road. So here width of the road is W. So we have to find an expression for W. So here there are the right angles, you can see. So in the smaller right angle, tan alpha we can write opposite side is height upon base. Opposite side upon base. This is our first equation. Then tan beta we can write height upon b. That is our second equation. So now from the first equation we can write h upon tan alpha is equal to a. This is our third equation. And similarly we can write h upon tan beta is equal to b. This is our fourth equation. So we have to find the width w. So w is equal to ab is equal to b minus a. So here we can write from here b minus a, values of b and a, that is h upon tan beta minus h upon tan alpha. So taking h common we get 1 upon tan beta minus 1 upon tan alpha. So simplifying this, it becomes h, and here it becomes tan alpha, taking the LCM, tan alpha into tan beta, and it will be tan alpha minus tan beta. So this is our expression for the width w. This is also a very important question. So this is the width. This is the expression for the width or the width of the road. So I think you all might have understood this question. So we are going to understand this question once more. Suppose there is a building which is having a height h, and at one end of the road there is a point A which is subtending an angle of alpha and which is at a distance of A from the foot of the building. And the other side of the road there is a point B which is subtending an angle of beta, and its distance from the foot of the building is B. So now we have to find the distance AB, which is the width of the road, that is W. We have to find its expression for the width of the road. So from the height and distance we can write tan alpha in the smaller right angle triangle, that is h opposite side upon base, that is h upon a. Similarly we can write in the bigger triangle, we can write tan beta is equal to opposite side, that is h upon the base, that is b. So from here we can write the values of a and b. A is equal to h upon tan alpha and b is equal to h upon tan beta. So now we can write the width. Width is equal to ab, that is b minus a. Substituting the values of b and a, we get h upon tan beta minus h upon tan alpha. So w is equal to h 1 upon tan beta minus 1 upon tan alpha. Taking the LCM, it becomes tan alpha, tan beta is the LCM. So in the numerator it becomes tan alpha minus tan beta and multiplied by h. So this is the expression for the width of the road. So I think you all might have understood this question. So now we are proceeding to the next question. So the next question is, there's a balloon and the balloon is rising. This is also a very important question, can come in your exam. This has come in the UP boards. So a balloon is rising, and suppose it has risen here, and here this is the center of the balloon, and here it is making an angle. You can see it is making an angle of 1 Suppose alpha from the center of the balloon. So we have to find the height, the distance of the center of the balloon from this point O, from where it has risen the balloon, and its vertical height is h. You can see h up, h is the height. So from here we have to find this distance, OA. OA we have to find. So we can write sine alpha is equal to h upon OA. So what will be OA? OA is equal to h upon sine alpha. So we can write h into cosec alpha. So this is the value of OA, or the distance of the point from the center of the balloon when it has risen. So I think you all might have understood this question. So we are going to understand this question once more. Sine alpha, it is making an angle of alpha from the center of the balloon, and the vertical height is h. So we have to find the distance OA. So OA is equal to h upon sine alpha, that is h into cosec alpha. So I think you all might have understood these questions. So please watch this video till the end, subscribe me and press the bell icon. Thank you.